Jai Hind children, welcome to today's class. Continuing with the section limits and derivatives. Today we are going to study some problems based on trigonometric limits. For trigonometric limits we need to study three important results. The result one is very important. The result one is limit x tends to 0. Sin x divided by x equal to 1. Very important is that the x which comes here, the same x needs to come in the denominator and that x needs to tend to 0. Then only you can apply the limit and the result will be equal to 1. Example, if your result is limit 2x tends to 0, then sin 2x divided by 2x need to come. The same 2x need to come in the denominator and the same 2x need to tend to 0, then only you can take the result as 1. But if your result is like this, or question is like this, if limit x tends to 0, sin 5x divided by 5x, then also you can write the result as 1. Even though the 5x is in the numerator, the same 5x in the denominator, but even if x tends to 0, definite that what happens when x tends to 0? When x tends to 0, 5 into x tends to 5 into 0, that is 0 itself. 5 into 0 is 0. So x tends to 0 is equivalent to 5x tends to 0. So even if here comes with x tends to 0, this you can replace as limit 5x tends to 0. Why? Because as x tending to 0, 5x tending to 5 into 0, 0. So the same limit is applicable here, sin 5x divided by sin 5x. Then you can write the result as 1. This is the first result or the basic result for trigonometric functions. Then result 2 is, this is the first result, limit x tends to 0, sin x by x equals 1. Now we can study what about result 2. Result 2 is limit x tends to 0, 1 minus cos x divided by x, that should be equal to 0. This is second limit. Limit x tends to 0, 1 minus cos x divided by x equal to 0. Remember, if an x comes here, the same x in the denominator and that x needs to tend to 0. For example, limit 2x tends to 0, then 1 minus cos 2x, the same 2x comes in the denominator, then only you can say as 0. Come with result 3. Result 3. Limit x tends to 0, tan x by x equal to 1. This is result 3. Here also the same x needs to come in the denominator, that x tends to 0. So these are the three important results for finding limits of trigonometric functions. First one, limit x tends to 0, sin x by x equal to 1. Second result, limit x tends to 0, 1 minus cos x divided by x equal to 0. And the result 3 is limit x tends to 0, tan x by x equal to 1. Now we are going to do the problems based on the same. First question, evaluate limit x tends to 0, sin 4x divided by sin 2x. Here you can't apply the limit directly. Our first method is the direct substitution method. What happens when x tends to 0? The numerator becomes sin 4 into 0 divided by sin 2 into 0. What about sin 0? 0 by 0, which is an indeterminate form, which is indeterminate. So for every limit, you need to apply the direct substitution method at first. When it becomes indeterminate, you need to move to the second step. Here the second stage is the given function is a trigonometric function. So think about the result. Limit x tends to 0, sin x by x equal to 1. This result we are going to apply here. We can take the given function as limit x tends to 0, sin 4x comes here, divided by sin 2x in the denominator. But you are known that if 4x comes here, the same 4x need to come in the denominator. So I am going to make an arrangement here as limit x tends to 0, sin 4x divided by limit x tends to 0, sin 2x. Why? Because you know that limit x tends to a fx by gx. For this, among the algebra of limits, you studied that you can apply the limit separately. Limit x tends to a, the numerator of x divided by the limit x tends to a, denominator gx. Algebra of limits. So the same limit I am going to divide for the numerator as well as for the denominator. Now we need to make a slight arrangement here. Limit x tends to 0. Here comes with a 4x. So the same 4x need to come in the denominator. Sin 4x in the numerator. Sin 4x in the numerator by, here I need to get a 4x in the denominator. So I am going to divide with a 4x and multiplying with a 4x. So no change of the value happens. The whole divided by, this is the adjustment in the numerator. Limit x tends to 0. Sin 2x in the denominator. So I am going to divide with a 2x. For not to change the value, multiplying with the 2x. Why? Because the same 2x need to come in the denominator for to apply the given result. This is our result. Limit x tends to 0, sin x by x equal to 1. You know that the same x comes to the denominator and that x need to set to 0. Now we are known that as x tends to 0, definite that 4 into x tends to 4 into 0, that is 0, and 2 into x also tends to 0. So the given limit becomes equal to limit x tends to 0 can be replaced with a 4x tends to 0, because x tends to 0 is equivalent to 4x tends to 0, sin 4x divided by 4x, the whole divided by, into 4x comes in the numerator, by limit x tends to 0 is the same as 2x tends to 0, sin 2x divided by 2x comes to the denominator into a 2x here with. Here x get cancelled. 4 by 2 can be cancelled and can be taken as 2. 4 by 2 can be cancelled and can be taken as 2. Now again we come to the algebra of limits. We have limit x tends to a constant k into fx. If it comes, the constant you can take outside the limit k into limit x tends to 0 fx. That property I am going to apply here. Here 4 by 2 is 2, which is a constant that I can take outside of the limit. Here limit x tends to 0 k into fx. If it is a constant, that constant can be taken outside of the limit. The same way, this constant 2 when comes outside of the limit, the remaining now is limit 4x tends to 0 sin 4x by 4x, the whole divided by limit 2x tends to 0 sin 2x divided by 2x, as the limit comes outside of the, the constant comes outside of the limit. Now you can see that the 4x here with the same 4x in the denominator and that 4x tends to 0. So in the numerator you can apply the limit as 1. So 2 into the numerator is 1 divided by the denominator 2x here with the same 2x comes to the denominator and that 2x tends to 0. that also the result is 1. Therefore, we can apply 1 in the denominator also. The reason is limit x tends to 0, sin x by x is 1. So, the final answer is 2. Come with second question. Evaluate limit x tends to 0, sin ax by bx. Here also, if you apply x at 0, what happens? Sin a into 0, 0 divided by b into 0, 0, which is an indeterminate form. In this case, you need to come to the second phase in which you need to apply the limit. Limit x tends to 0, we have sin x by x equal to 1. We are going to apply this limit. Taking the given limit as limit x tends to 0, sin ax by bx is our question. Make a slight arrangement as limit x tends to 0. Keep the 1 by bx aside. This 1 by bx you need to keep aside. And then the remaining is sin ax only. That sin ax, you need to, the same ax comes in the denominator. So, I need to multiply with an ax in the numerator. But it is clear for you that when x tends to 0, ax tends to 0. So, no problem with the limit as limit x tends to 0. So, which is equivalent to limit x tends to 0, which is the same as limit x tends to 0. And now, the remaining is sin ax by ax into, now remains here is ax into 1 by bx, so that this x cancel with this x. So, the remaining is a by b, a into 1 by b, which is a by b. But a by b is a constant that you can take outside of the limit, because limit k into fx equal to k into limit fx. So, limit x tends to 0. This a by b is a constant that we can take outside the limit. The remaining is sin ax by ax. Now, it is okay with the ax comes here, the same ax comes in the denominator. If x tends to 0, x tends to 0, so that this much limit becomes equal to 1. So, the result is a by b into 1, which is a by b. Another question. Evaluate limit x tends to pi, sin pi minus x divided by pi into pi minus x. When applying with the value for pi, it becomes an indeterminate form 0 by 0, because pi minus pi becomes equal to 0 divided by, here also pi minus pi becomes equal to 0, which is an indeterminate form. So, we are going to discuss with the phase 2. The given limit can be replaced as limit x tends to pi into, this 1 by pi is a constant. 1 by pi, really it is a constant. This constant I am going to keep aside as 1 by pi into, the remaining in the numerator is sin pi minus x divided by, in the denominator there is a pi minus x. This 1 by pi constant that you can take outside of the limit and can be written which is equal to 1 by pi into limit x tends to pi sin pi minus x divided by pi minus x. Now, you are known that when x tends to pi, what happens to pi minus x? Pi minus x tends to pi minus pi, which tends to 0. So, when x tends to pi, this pi minus x tends to 0. So, this limit we can arrange as which is equal to 1 by pi into limit x tends to pi is equivalent to pi minus x tends to 0. Why? Because here sin pi minus x, the same pi minus x in the denominator. So, as per our standard limit, if here is the pi minus x, the same pi minus x need to come in the denominator, and that pi minus x tends to 0. So, x tends to pi is equivalent to pi minus x tends to 0. Now, this much result you can apply as the standard result as 1. So, the remaining is 1 by pi into the standard result 1. So the answer is 1 by pi. Another important question. Evaluate limit x tends to 0 cos 2x minus 1 divided by cos x minus 1. Here also when applying with the value for x at 0, cos 0 is 1, 1 minus 1 by 1 minus 1, 0 by 0, which is then indeterminate form. So we need to come to the phase 2. The given limit can be replaced as limit x tends to 0. You know the formula for this can be rearranged as cos 2x minus 1 can be rearranged as 1 minus cos 2x. So that here comes with a negative sign when reversing, minus of 1 minus cos 2x divided by. Here also minus of when taking common outside 1 minus cos x. These two negative signs get cancelled and we can arrange it as limit x tends to 0, 1 minus cos 2x divided by 1 minus cos x. You know the trigonometric formula for 1 minus cos 2x is 2 sin square x. If the angle here is 2x, the half angle will come here as x. So the formula for 1 minus cos x will be equal 2 sin square. The angle here is x, the half angle x by 2 will come here. This result I am going to apply in the numerator and denominator. So that equals limit x tends to 0. The numerator 1 minus cos x can be replaced with a 2 sin square x divided by 1 minus cos x can be replaced as 2 sin square x by 2. Again 2 get cancelled. Now we can arrange this as equals limit x tends to 0 sin x divided by sin x by 2 the whole square, because both of them have square. Sin square x is equivalent to sin x the whole square and sin square x by 2 is equivalent to sin x by 2 the whole square. So both of them can be included in a single limit. Now for to apply the standard limit, I am going to make an arrangement here as limit x tends to 0 within the bracket. The numerator is sin x. So for to apply the standard limit, the same x need to come with the denominator. That x need to multiply on the numerator, the whole divided by. Now sin x by 2 in the denominator. As x by 2 comes to the denominator, the same x by 2 I am going to dividing by and multiplying here with. But don't forget this will be within the square. This much will be in a square. Again we can arrange. Before arranging, you know that a cancellation there with x can be cancelled with x. Now the remaining is I am going to make an arrangement equals limit x tends to 0 sin x by x comes in the numerator by sin x by 2 by x by 2. This much sin x by 2 by x by 2 is the denominator. Sin x by x is the numerator. So sin x by 2 by x by 2, that comes in the denominator by x by 2. That comes in the denominator into the constant there with is 1 divided by this much comes within a square. This much in the square. But inside the square there is a constant 1 divided by 1 by 2. That can be written as 1 by 1 by 4, because 1 square is 1 by 1 by 2, the whole square is 1 by 4. But this is the constant that you can take an outside limit. 1 by 1 by 4 is equivalent to, when taking the reciprocal and simplify, 1 by 1 by 4, which is equivalent to 4. Write the first fraction, take the reciprocal and multiply, so you get as 4. That 4 is a constant that we can take an outside the limit as 4 into limit x tends to 0 sin x by x the whole square, separating the limit, divided by limit x tends to 0 sin x by 2 by x by 2 the whole square. 4 into limit x tends to 0 sin x by x into limit x tends to 0 sin x by x. This is what we mean with sin x by x the whole square, because we know the algebra of limit x tends to a into b can be replaced as limit x tends to a into the first function or a or x fx into gx can be replaced as limit x tends to a fx into limit x tends to a gx. Separate limit we can apply as per the algebra of limits. So sin x by x the whole square is equivalent to sin x by x into sin x by x. That when separating with the limit can be given as two separate limits, the whole divided by. The same is the case of denominator also. Limit x tends to 0 sin x by 2 by x by 2, and one more limit as it is a square, limit x tends to 0 sin x by 2 by x by 2. Now before applying the standard limit, you know that here x, the same x here, that x tends to 0, so the value is 1. Here x, the same x comes in the denominator, that x tends to 0, the value is 1. Here the same x by 2 comes in the denominator, but x tends to 0 is equivalent to x by 2 tends to 0 by 2, which is 0. So x tends to 0 is equivalent to x by 2 tends to 0. So no problem. Here also the same thing. So the final answer is 4 into the numerator. The first limit is 1 into the second limit is 1 divided by the denominator also 1 into 1. The net answer is 4. A very important question. One more question of the same type that we can discuss. An important question. Limit x tends to 0, ax plus x cos x divided by b sin x. In all the questions, you need to keep in mind about the standard 3 limits and making an arrangement herewith. Here, I am going to make an arrangement as limit x tends to 0. This can be written as ax by b sin x, giving the denominator separately, ax by b sin x plus x cos x by b sin x. This is the first step. That is separating the denominator for both the terms x plus x cos x in the numerator. Now, this we can arrange it as equal to limit x tends to 0, limit x tends to 0. Look at the way I am going to arrange. A divided by b sin x here with, on the numerator there is an x, that I am going to keep it in the denominator. Why? Because taking the reciprocal and multiplying, this x comes in the numerator. So just an arrangement only, plus this limit I am going to write as limit x tends to 0, x cos x by sin x can be written as cot x by b. X cos x by sin x, this much is cot x, cos x by sin x. This much will become as cot x. Now, again our arrangement as equals limit x tends to 0, a by b into sin x by x, keep it there, plus this I am going to arrange it as limit x tends to 0, x into cot x can be written as 1 by tan x. Now 1 by b also remains there, 1 by b remains there. Again an arrangement as equal to limit x tends to 0, a by b, this I am going to keep it separately as a by b, this a by b here with a by b into 1 by sin x by x, sin x by x with the first bracket, plus this I am going to arrange it as limit x tends to 0, 1 by b therewith into 1 by tan x in the denominator This x can be written as tan x by x. Why? Because 1 by tan x by x. 1 by tan x by x is equivalent to x by tan x. So, this x by tan x I arranged as 1 by tan x by x. Okay, we can apply the limit equals a by b is a constant that you can take outside of the limit as a by b into limit x tends to 0 1 by sin x by x plus here 1 by b is a constant that you can take outside limit x tends to 0 1 by tan x by x. Now your rounded equal to a by b into the numerator is 1 by denominator limit theta tends to 0 sin theta by theta 1 plus 1 by b into here the numerator is 1 by denominator limit theta tends to 0 tan theta by theta is 1. So the answer is a by b plus 1 by b, which is the same as a plus 1 by b. Now we need to find the limit of a function at a particular point. Come with the question, find limit x tends to 0 fx, where fx equals 2x plus 3 when x less than or equal to 0 and 3 into x plus 1 when x is greater than 0. Here the function takes two values. When x is less than or equal to 0, that is in this range from x is less than or equal to 0, the function takes the value 2x plus 3. But when x is greater than 0, that is in this area, when function take the value x greater than 0, the value of the function is 3 into x plus 1. But in the last class you studied that to find the limit of a function at the point A, you know that the left hand limit at the point A must be equal to the right hand limit at the point A. You know what left hand limit? Left hand limit means limit x tends to a minus, and that should be limit x tends to a plus. If both of them will be equal, then only we can say that the limit exists. This we already studied on last class. In the same way, here I am going to test whether the function exists and has the same value. At first we can find the left hand limit LHL. LHL means limit x tends to 0 minus. 0 minus means that the function doesn't take the value 0, but instead it is approaching 0 from the left side. That is 0 minus. 0 minus means that the function approaching 0 from the left side. In that case, when function take the value less than 0 or when function is approaching 0 from the left side, the value of the function is 2x plus 3. Identify that. In how to find the limit of this is limit x tends to 0. Here you can substitute with the value of x as 0. 2 into 0 plus 3 equals 2 into 0 is 0, 0 plus 3 is 3. So the left hand limit value is 3. Here the value of the function is 3 in the left hand side. Now we can take the right hand limit RHL. RHL is limit x tends to 0 plus. 0 plus means that function approaching 0 from the right side. By that time 0 plus fx equals limit x tends to 0. When the function is approaching 0 from the right side, the value of fx is 3 into x plus 1. Now we can substitute the value of x as 0, so that 3 into 0 plus 1, x can be taken as 0. So the answer is 3. So LHL equal to 3 and RHL also equal to 3. When the LHL and RHL are equal, therefore the left hand limit equal to the right hand limit, therefore the function exists. The function or the limit exists. The limit exists and the value of the limit, merging that limit x tends to 0 minus and limit x tends to 0 plus, that we can merge this limit x tends to 0 fx the value of the function at x equal to 0 equal to 3. This is the answer. Come with the next question. Find a limit x tends to 0 fx, where fx equal to mod x by x when x not equal to 0 and 0 when x equal to 0. The problems relating with the modulus function seems to be very important. You know what the definition of mod x? Mod x equal to minus x when x is less than 0. That is, for all negative values, mod x takes the value minus x and equal to plus x when x is greater than 0. This you studied in the chapter relations and function, what the modulus function is. The definition of modulus function is mod x equal to minus x if x less than 0 and x if x greater than 0. Okay, we can come with our function in which for all values x not equal to 0, so consider the 0 as a critical value, and for all values of x not equal to 0. Not equal to 0 means that even if the function approaches from the left side, or even if the function takes the value from the left part of 0, the value of the function is mod x by x. And as x not equal to 0, the value of the function on the right side is also mod x by x. But at the point x equal to 0, the value of the function is 0. At the point 0, the value of the function is 0 itself. So here, that for two regions, x less than 0 and x greater than 0, in these two regions, the function has the same value mod x by x. But when it comes to the negative part, the value of mod x becomes minus x as x is less than 0. When x less than 0, the value of modulus of x becomes minus x divided by x. Remember that. Now we can find whether the limit exists or not. I am going to find the left hand limit at first. LHL equals limit x tends to 0 minus approaching 0 from the left side fx equals limit x tends to 0. This is the way to do the problem. Limit x tends to 0 minus can be replaced as limit x tends to 0, but the value of function when x tends to 0 minus, that is, what the value of the function in the left part of 0, that is mod x by x. But that will be equal to limit x tends to 0. When x is less than 0, the value of the function is minus x divided by x. This x gets cancelled, which is equal to limit x tends to 0 minus 1. Minus 1 is a constant and that can be taken out of the limit, so the answer is minus 1. Thus you got the LHL as minus 1. Now we can check with the RHL, the right hand limit. Limit x tends to 0 plus fx equal to limit x tends to 0. How we can find limit x tends to 0? 0 plus fx means that the value of the function on the right side of 0, that also is modulus of x by x, which is equal to limit x tends to 0. On the right part of x, mod x is same as x itself, because as x greater than 0, the value of mod x is x. So x divided by x. The value of mod x is minus x or plus x. Accordingly, the value is on the left side or on the right side. Now, which is equal to limit x tends to x by x is x tends to 0, x by x is 1. So the answer is 1. Here you can see that LHL is minus 1 and RHL is plus 1. So LHL are not equal to RHL. Therefore, limit x tends to 0 fx does not exist. Does not exist. Another question. Suppose fx equals a plus bx when x is less than 1. For if x equal to 1 and b minus x when x greater than 1. And if limit x tends to 1 fx equals f of 1, what are the possible values of a and b? In the given function, there are constants a and b. You are asked to find the values of a and b. This is the given condition. Limit x tends to 1 fx is given as equal to f of 1. When x is less than 1, that is at this portion, When x is less than 1, the function takes the value a plus bx. At sharp equal to 1, the function takes the value 4. And when x is greater than 1, the function takes the value b minus x. So, this much area, the function takes the value b minus x. At first, we can find the LHL, left hand limit, equals limit x tends to 1 minus fx. Why? Because 1 is the critical point here. Listen to the question, 1, 1, 1. So, take the LHL for the point 1. Limit x tends to 1 minus fx equals limit x tends to 1. What is the value of the function when x approaches function from the left side? 1 minus. So, the value of the function is a plus bx. Now, we can substitute the value for x at 1. So you get a plus b into 1, which is a plus b. Thus, LHL obtained to us a plus b. Now, we can find the RHL. RHL equals limit x tends to 1 plus fx. That is the value of the function approaching 1 from the right side equals limit x tends to 1. What is 1 plus fx? The value of the function on the right side of 1 is b minus x. Now we can substitute the value of x as 1. We get b minus a into 1, which is b minus a. Thus you got the RHL, right hand limit, as b minus a. But limit x tends to 1 minus fx and limit x tends to 1 plus fx need to be equal for a limit to exist, and that we can merge as limit x tends to 1 fx. But this limit x tends to 1 fx is given to us f of 1. Means that what is the left hand limit? Left hand limit is a plus b, and that is equal to what is the right hand limit? B minus a equal to what is the value of the function at x equal to 1? F of 1. F of 1 equal to 4. From this, you get two equations, a plus b equal to 4, equation number 1, and b minus a equal to 4. That you can take as equation number 2. Solving 1 and 2, you can find the values of a and b. A plus b equal to 4, equation 1. B minus a equal to 2. B minus a equal to 4, that is equation number 2. Solving, we get adding 1 and 2. Adding 1 and 2, we get plus a minus a get cancelled. So b plus b, 2b equal to 8, which implies b equals 4. Substitute the value of b in any of the equations, we get a plus the value of b is 4. I am substituting in 1, a plus 4 equal to 4, which implies a equal to 0. Therefore, the values of a are a equal to 0 and b equal to 4 are the possible values. Very important question.